Welcome. This is chapter 12 of object-oriented programming. Ignore that it says Visual C# 2012. This is, I'm still using Visual Studio 2017. We're going to be talking about polymorphism, interfaces, and operator overloading. So let's jump right into it. So in this chapter, we're going to talk about how polymorphism enables you to program in the general. Not specifically, but generally, so you can use the classes or base classes, derived classes over and over and over again. We're also going to talk about how to make your systems extensible. We're going to talk about the use of overridden methods that affect polymorphism. We're going to learn and talk about how to create abstract classes and methods. We're going to talk about how to determine an object's type at execution time. We're going to talk about how to create sealed methods in classes, how to declare and implement interfaces, how to overload operators and enable them to manipulate objects. And this is what we're going to talk about. In a nutshell, here's the outline. And more of the same. Alright, so what's polymorphism? Polymorphism is an old methodology. It comes from the original object-oriented programming methods, and what it really does is it enables you to write apps that process objects that share the same base class in a class hierarchy as if they were all objects of the base class. Polymorphism promotes extensibility, meaning that you can use other classes at your disposal. Well, you have other classes at your disposal, so you don't have to rewrite code. Just think about it as modularity, right? So, and this is something that I talked about in the last chapter, but let's take shape for example. So the shape base class has many different individual classes that are derived from it. You can have and this is something that I just wrote in my head, you can have the circle class, you can have the square class, and you can have the triangle class. Well, under these classes, under these derived classes, you can have even more classes. So for instance, under the square class, you can have quadrilateral, you can have rectangle, and the like. So why is that important? Well, if the class rectangle is derived from class quadrilateral, then a rectangle is a more specific version of a quadrilateral. So in this case, if this circle class here is derived from your shape class, which is your base class, then the circle class is a more specific version of the shape class. Any operation that can be performed on the quadrilateral object can also be performed on the rectangle object, as here. Any operation that can be performed on the shape object can be performed on the circle object. These operations also can be performed on other quadrilaterals, such as squares, parallelograms, and trapezoids. Just understand that a quadrilateral is an object that has four angles. The polymorphism occurs when an app invokes a method through a base class variable. As another example, suppose we design a video game that manipulates objects of many different types, including objects of classes Martian, Venetian, Plutonian, Spaceship, and Laserbeam. Each class inherits from the common base class space object, which contains the method draw. A screen manager app maintains a collection, a space object array of references to objects of the various classes. To refresh the screen manager periodically sends each object the same message, namely draw, while object responds in a unique way. So, polymorphism promotes extensibility. Software that invokes polymorphic behavior is independent of object types to which messages are sent. New object types that can respond to existing method calls can be incorporated into a system without requiring modification of the base system. Only client code that instantiates new objects must be modified to accommodate new types. So what does this mean? This means that if you have a base class, so let's take something that might be relevant to us, student, for instance, right? How many different types of students can you have? Well, it depends on your institution. Let's say you have undergraduate and graduate. These are derived classes of the base class student, but that doesn't stop there. You can also have different undergrad students and different graduate students. Let's break that down into a hierarchy. Let's say we have the science department, let's say we have the arts department, and let's say we have the journalism. Okay? The same can be said for graduate, and so on and so forth, and so on and so forth, and so on and so forth. What makes polymorphism nice is we're extending the student class all the way down to these other classes. So we don't have to write the same crap we wrote in the student class in the science student class or in the undergraduate student class. They're inherited from the student class, which means that new object types that can respond to existing method calls can be incorporated into a system without requiring modification of the base system. Everything that happens here can also happen here. That's the power of polymorphism. So, in a method call on an object, the type of the actual referenced object, not the type of reference, determines which method is called. An object of a derived class can be treated as an object of its base class. A base class object is not an object of any of its derived classes. This is a relationship applies from a derived class to its direct and indirect base classes, but not vice versa. What does that mean? That means if I have a shape class, and that shape class is then pushing all of its methods and variables and, well, methods and properties down to the circle class. The circle class cannot push back towards the base class. It is only one way, back, downwards. Which is why I said when I saw that screenshot and it had the arrows going up that I said that's kind of confusing. Because normally you have your base class on top that has all your generic, your generic methods inside it. And what it does is it pushes its methods down to all the other classes that would specifically need it. For instance, in this case, draw. If you want to draw the shape on the screen, the shape class would handle that method for you and push that down to other shapes. That means that the circle class does not have to actually implement a draw method. All it has to do is use the base dot draw, if the method's name would be draw. And in that case, what happens is, what we're actually saying is whatever our base class is, in this case shape, I want to use the method draw from it in the circle class. And if I use the moniker virtual before draw in the base class, then I can actually override this method and write other things that I want that method to do in the circle class. This is called an is-a relationship. The compiler allows the assignment of a base class reference to a derived class variable if we explicitly cast the base class reference to the derived class type. If an app needs to perform a derived class specific operation on a derived class object referenced by a base class variable, the app must first cast the base class variable to a derived class reference through a technique known as downcasting. This enables the app to invoke derived class methods that are not in the base class. Now, 12.1 demonstrates 3 ways to use base class and derived class variables. In the end, you don't want to use variables that are in your base class. What you want to do is you want to have properties that can be used to shuffle data back and forth to the private variables that exist in your base class. So in this case, we have commission employee and base commission employee. The instantiation of both of these objects have been made and are added to the specific variable names that were written. So base plus commission employee holds the instantiation of base plus commission employee object, as well as the new commission employee information holds that into the commission employee object. This is the main function. So what they're doing is they're instantiating both of those objects, and then they're writing from the object. So it executes the toString, and then it executes the earnings. Same for this one. So they took the base plus commission employee object and they added it to commission employee 2, and then they did this writing again. Interesting. Very interesting. There should have been 3. Oh, okay. I was wondering what was going on. There should have been 3 write-outs. So this is the first call for commission employee. This is the second call for a commission employee with the overridden methods of toString and earnings, derived from the base class, and used in the derived class object. This is the derived class object. Let's go back so I can show you what I'm talking about. Remember, we instantiated commission employee, then we instantiated base plus commission employee. This is now a derived class object. This is the derived class object. This is the base class object. What we essentially did was we took the derived class object and we used a base class method. Earnings is a base class method that we overrode in the base class commission employee hierarchy. And if you don't remember when we did that, go back and watch chapter 11. And we went over this already, the way this is all set up. If you want to follow along, you can go to the chapter 11 PowerPoint that's in module 5, And if you go all the way to the end, you'll see the base class, base plus commission employee derived class. That's inheriting the commission employee base class. But we didn't call earnings from base plus commission employee. We called earnings from the base class. We overrode it in the derived class, but that doesn't change where it is. It still exists in the base class. So, well, the reference exists in the base class. So what we essentially did was we used the derived class reference from the base class, and we added that, or we used it from the derived class object. Remember, both of these methods are being overridden. This method is being overridden both from the object class, which is the base of commission employee, and from commission employee. This is also being overridden by base class commission employee. And here we go. Call base class commission employees to string earnings methods with the base class reference to derived class object. Where's the base class reference? Let's go back and look. So this is the last call that we did right here. We said, I want the base class commission employee object to be in the commission employee 2 object with the commission employee data type. That means it's no longer a derived class object, it's a base class object, because we said I want to use the base class data type. And then we did our methods off of the base class. And if you look, the data is pretty much the same. There's only one difference. Well, hold on. 0, 4, 3,000. No, there is no difference. Right. So, yeah, same thing. The only thing we did was we used the derived class object with base class references. When the compiler encounters a virtual method call made through a variable, the compiler checks the variable's class type to determine if the method can be called. At execution time, the type of the object to which the variable refers determines the actual method to use. Alright, so let's get to the age-old moniker of abstract classes. This is actually very important because you're going to get asked this question a heck of a lot when you interview and whatnot, and it can be rather annoying. But just understand that abstract classes, or more specifically, abstract-based classes, cannot be used to instantiate objects. I will say that again. Abstract classes, or abstract-base classes, cannot be used to instantiate objects. So, let's go back. What we did here, when we instantiated commission employee into the object commission employee, you cannot do that when you have an abstract base class. So technically, abstract base classes are amazing when you want to use it to derive things into a derived class. But you can't use the abstract base class as an object. You just can't. Abstract base classes are too general to create real objects. They specify only what is common among derived classes. So, if we can't use it as an object, then why use it? Well, classes that can be used to instantiate objects are called concrete classes. Remember me talking about concretions and abstractions? Well, concretions are when you can actually create an object from the blueprint. Remember what a class is. The class is nothing but a blueprint. So what I can do is I can either say, okay, I have a blueprint. I want to use that blueprint to make cups. Okay? Or ice cream cones, however you look at that. And I can make this blueprint make more than one cup. I can tell it to make as many cups as I want, as we did here. If we go back, let's just, for an instance, take my example. We made the first cup here. This is the first cup that we made. Then we said, oh, wait a minute, I want to make another cup. So we made another cup. That's called the concretion. They are concrete objects. Now, what's the problem with concretions? Well, the pro of a concretion is this. Concretions can be used wherever they've been created, and they're very fluid. However, concretions can be bad if they don't destruct themselves or remove themselves from memory. You can have a situation where your website or your program is bogged down because you just have way too many concrete objects all over the place that didn't go away after you told it to go away. And that's an issue with concretions. These are concretions. Concrete classes are nice when you need to manipulate an object, but they're not always nice. That's why we have two other ways of doing things. We can create what's called abstract classes that can't be created into anything. They're literally just a blueprint. Or you can use what's called dependency injection. Now, if you don't know what dependency injection is, I don't know if we're going to go over that in this class. I would love to. But dependency injection is the alternative to concretions. As a matter of fact, you'll find that we're moving away from concretions very quickly and very quickly going into dependency injection. But today, I think we're just going to talk about abstract classes. So, concrete classes provide the specifics that make it reasonable to instantiate objects. So, an abstract class normally contains one or more abstract methods, which have the word abstract in their declaration. A class that contains abstract methods must be declared as an abstract class even if it contains concrete, non-abstract methods. So, a class that contains abstract methods must be declared as an abstract class, even if it contains both abstract methods and concrete methods. Abstract methods do not provide implementations. Now, you might be asking me, what in the heck is an implementation? Well, let's go back. What we see here, or actually, no, I'm too far back. Can I go, is there any more, do we didn't have any code in this one? Okay, too easy. So, let's minimize that, Let's move over, and I'll show you exactly what a concretion is. Oops. Alright, so we have our base salary class here. Alright, and if I scroll down, this is called an abstraction. This is an implementation. This is what the meat and potatoes of your program is supposed to do. When you have an abstract class, the abstract class shouldn't have any abstractions, or implementations or statements of code in it. It should just tell you what the method actually is. That's it. Alright. Abstract property declarations have the form of public abstract, the property type, and the property with your get sets. Okay. An abstract property omits implementations for the get assessor and or the set assessor. Concrete derived classes must provide implementations for every assessor declared in the abstract property. Constructors and static methods cannot be declared abstract. The reason why is because static methods, okay, are going to be used within the same class. I can't use, so let's flip back over for a second. That's annoying. Hold on. Whatever. Yeah. All right, I have to remember in my head that it switched over and hope that it did. All right, so constructors and static statements methods cannot be declared abstract. Why? Because if you declare a constructor abstract, then you can't write anything into that constructor. Nothing can be written here. The same for static methods. Now, why do I need static methods? Well, if I wanted to use, so let's say I had a method called public decimal integer or number. Ooh, that's annoying. Number. Move that out of the way. And I said I want you to return 1 plus 1. Okay, so that should be fine, right? Well, if I wanted to use this number and I put it here, right? I said, okay, I want to use a number in my constructor. When this constructor fires, I want to say number. Can I do that? Quite possibly. All right, maybe that's not a good example. Say I wanted to use that method somewhere else. It should not let me do that, actually. That's interesting. Oh, right. I'm screwing the pooch right now. I know why it's not working. All right. Save. Oh, wait. No, I know what's not working. if I wanted, so let's not do this. If I wanted to say commission employee, and I said, hey, I want to use the base commission employee dot. Now, you notice how there's no method there? Now watch this. If I wanted to call the base plus commission employee number method in another class, I can make it static. And once I do that, where are you? There you are. I should be able to see it. There it is, number. And I can call number in another method from the base commission class. Now, I don't want to do that, and this is something you actually don't want to do a whole lot. It's good when you need it, but in the end, if you really need something like that, then you should use a concretion or use dependency injection. But that's the way that works. Okay. An abstract class declares a common attribute and behaviors of the various classes that inherit from it, either directly or indirectly in a class hierarchy. An abstract class typically contains one or more abstract methods or properties that concrete derived classes must override. The instance variables, concrete methods, and concrete properties of an abstract class are subject to the normal rules of inheritance, which means that even though an abstract class does not contain implementations, your abstract class will not only adhere to the normal rules of inheritance, but the concrete derived classes must override. They must override the abstract class methods. Attempting to instantiate an object of an abstract class is a compilation error. We talked about this. Abstract classes cannot be instantiated. Don't say new, class if you have it as an abstract class. Failure to implement a base class's abstract methods and properties in a derived class is a compilation error unless the derived class is also declared abstract. We can use abstract base classes to declare variables that can hold references to objects of any concrete classes derived from those abstract classes, which is kind of nice because all of your variables and all of your, properties for that matter or whatnot can be contained in an abstract class. And what that essentially does is it makes it so that you don't have to have variables all over the place. You have it in one place. You can use such variables to manipulate derived class objects polymorphically and to invoke static methods declared in those abstract base classes. And I just showed you how you can use static methods. If you inherited the abstract class, you didn't have to do it the way I did it, but c'est la vie. In this section, we create an enhanced employee hierarchy to solve the following problem. So I'm going to read it. So let's read it. A company pays its employees on a weekly basis. The employees are 4 types. Salaried employees are paid a fixed weekly salary, regardless of the number of hours worked. Hourly employees are paid by the hour and receive time and a half overtime pay for all hours worked in excess of 40 hours. Commission employees are paid a percentage of their sales, and salaried commission employees receive a base salary plus a percentage of their sales. For the current pay period, the company has decided to reward salaried commission employees by adding 10% to their base salaries. The company wants to implement an app that performs its payroll calculations polymorphically. We use abstraction class employee to represent the general concept of an employee. So, the employee class is going to be abstract. And we have to extend employee, or employee will be inherited by, salaried employee, commission employee, and hourly employee. Class base commission employee, which extends commission employee, represents the last employee type. Commission employee seems to be a derived class, deriving itself from the employee class, which is an abstract class. The UML class diagram of figure 12.1 shows the inheritance hierarchy of our polymorphic employee payroll app. So employee is the abstract class, which is inherited by the salary class. I hate it when the arrows go up. That just makes it really confusing. The employee abstract class, so this is an abstract class with no implementations, is inherited by salaried employee, commission employee, hourly employee, and base commission employee, even though you don't see it. Then, base plus commission employee inherits commission employee. Class employee provides methods earnings and to string, in addition to the properties that manipulate employees' instance variables. Each earnings calculation depends on the employee's class, so we declare earnings as abstract. The app iterates through the array and calls method earnings for each employee object. These method calls are processed polymorphically. Each derived class overrides method to string to create a string representation of an object of that class. The diagram on 2.3 shows each of the 5 classes in the hierarchy down the left side of the method earnings into string across the top. And here we go. Employee is an abstract has abstract earnings. Employee is an abstract class, and the toString. Earnings is abstract. Oh man, words. And then toString is not. toString actually contains some properties. It contains first name. It contains social security number. It contains last name. Salaried employee then adds and overrides this earnings abstraction into weekly salary, and so on and so forth. And you can see how the earnings is changing as it goes down, but all we're doing in the toString is adding more and more things. So, and this is what it looks like. This is an abstraction. All right. So we have the public abstract class. We have the get sets. Okay. These are our properties. Remember, first name, last name, and social security are read-only. They are read-only. We assigned the private assessor to the set value. We don't want anything being set to the property social security number. And then we have a 3-parameter constructor. Employee is what? The name of the abstract class, right? We want the first name, the last name, and a social security number. And that's how, and then we add all those to our properties. We then have a string method that's being overridden. Remember where toString comes from. toString comes from the object class. So in order for us to use it the way we want to, we have to override it, which we did. And then we created an abstract class, an abstract method called earnings. Now, if you create an abstract method, you have to override that method everywhere. Every place that this class, this abstract class is being used, every place that is the inheritor, is being inherited, has to have an overridden derived class. Everywhere. That's what happens when you call an abstract method. Unless, of course, that class, the derived class, is abstract. Then you don't have to do it. But in every other derived class, which is not abstract to employee, because we call this method earnings abstract, it has to be overridden by all of them. All of the classes have to override it. So here's the salaried employee's class declaration. We have salaried employee, which is inheriting the employee class. We have a private decimal weekly salary variable. And we then have the constructor, the salaried employee constructor, which contains the first name, the last name, and social security number, and the salary. But the only thing that we are going to pull in our constructor at this point is the salary. The reason why? The base class is pulling in the rest of it. We have weekly salary as a property here with a set value if-else statement. We then, as we are supposed to do, override the decimal earnings method to only return the weekly salary, because that's all we really want. Then we override the toString method that was overridden in the employee class here. And then we display the weekly salary. The hourly employee's class declarations is shown. We have hourly employee, which is inheriting from employee class. There are 2 variables in the hourly employee class, wage and hours. We need to know the wage and the hours of each hourly employee to calculate their payroll. We then, in our constructor for hourly employee, we ask for the first name, the last name, the social security number, the hourly wage, and the hours worked. But the base class is what's going to do the work to get the first, last, and social security number. So in this case, all we really care about is wages and hours. What's not being called by the base class. And we save those to our, if you can tell, we're saving it to our properties. These are not the variables, wage and hours. If you look, this is lowercase wage, lowercase hours. This is an uppercase wage and uppercase hours. These 2 things are properties. Oh, would you look at that? Oh, ho, ho, it's magic. We use a property, a public property, to save our data, to set our data to the variable wage, because we don't want to expose that variable outside of this class. We also do the same thing for hours. And we have a set if statement. If the value of hours is greater than or equal to 0, and the value of hours, remember value is the value of the property, is less than or equal to 168, then save the value. Otherwise, throw an error. By the way, 160 is a 2-week period. 8 hours over, that's overtime. Then, as we have to do in every class that inherits employee, we have to override earnings, because earnings is a what? Abstract method. So, if the hours is greater than or less than or equal to 40, yeah, then give me the wage times the hours. Remember, wage here, that's a method. I'm sorry, that's a property, and hours is a property. Otherwise, I want you to do some calculations to give them overtime. And then we override the toString, because the toString is overridden by the employee base class, the employee base abstract class, because the object class that is inherited by all classes, if you will, has a toString method that we were already overriding. So let's go over the commission employee class. This is fun. I love doing this. Commission employee is our derived class, which is inherited the employee abstract base class. Once again, the only variables we need in the commission employee class is the gross sales and the commission rate, and they're both set to private. Then in the constructor for commission employee, we have the first, last, social security number, sales, and rate. But because the base abstract class is pulling the first, last, and social security number, we only care about sales and rate. So what did we do? We pulled sales and rate, and we assigned it to the public property gross sales and the public property commission rate. How do I know those are properties? Because of the way we did the casing. Uppercase, uppercase. Lowercase, uppercase, lowercase, uppercase. So, the decimal public property gross sales either returns the gross sales private variable, or it sets it based on whether the value is greater than or equal to 0. The same is true for commission rate. Then, we override the earnings. Do you see a pattern here? I don't know. Do you guys see a pattern? We're overriding the decimal earnings. And we're doing the method transformation on commission rate times gross sales. Fancy that. And then we override to string. It's over and over and over and over and over again. Give me a second. I gotta catch myself. Getting excited. This makes me really happy because it makes it simple. You're breaking it up. It just makes more sense when you do it this way. All right, so let's keep going. I think there's a couple more left, actually. Oh, and then base class commission is extending commission employee, and therefore is an indirect derived class of class employee. Because base plus commission employee is using commission employee as its base class, it is also using employee as its base class as well, because commission employee uses employee as its base class. So this is an indirect base class. Commission employee is now an indirect base class. And this is the way it looks. So base plus commission employee is inheriting from the commission employee class. What the base plus commission needs is base salary. And it's using base salary as a private assessor. The base plus commission employee is the constructor for base plus commission employee needs the first name, the last name, the social security number, the sales, the rate, and the salary. But because the base class is giving us the first, last, social security number, sales, and rate, all we really need is the salary. So we pull the salary and we place it into the public property base salary. There you go. Base salary gets the private variable when it needs to return the value. If not, then it sets if the value of base salary's property is greater than or equal to 0. Then guess what it's doing? It's overriding the abstract method earnings. Because in every method that is abstract, it needs to be overridden in every derived class. I will say that again. Every method that is abstract must be overridden in every inherited class, in every derived class, unless the derived class is also abstract. And in this case, we say base.earnings to pull the earnings method from where? We're pulling it from commission employee, and we're doing some magic on it. Then we override the toString because the toString was overridden in the commission employee class, which was also overridden in the employee class, which is our abstract base class, which overrode toString from where? The object class. So this is our employee hierarchy. We're not testing it. We have salaried employee that's being instantiated as new salaried employee. We have hourly employee, which is being instantiated as hourly employee. We have commission employee, which is being instantiated as commission employee. We have base plus commission employee, which is being instantiated as base plus commission employee. And then we write everything. We write it. And then there's an employee array. Create a 4-element array. Now, why do we do this? Well, in C# or C in general, when you create an array, the array cannot be dynamic. It must be a fixed array because arrays only hold consecutive memory values. Excuse me. Arrays hold consecutive memory values in the memory cache. So to conserve memory, you have, or so that you don't have, insane buffers, you tell it, hey, I only want 4 employees. And what we're doing here is we're assigning a value to each derived type. Are you a salaried employee? Are you an hourly employee? Are you a commission employee? Are you a base commission employee? These objects, because that's what they are being saved into the array. So now employees can be processed what's called polymorphically. And here's a for each statement that does it. For each employee, current employee in employees, which is here, this is employees, the array employees. So we're iterating through the array employees. For each employee, or for each current employee, and also remember, the data type has to remain the same. So if the array data type is string, then what this would say is for each string x in whatever the name of the string array is, if this was integers, it would have to be for each int x in whatever the name of the array is. So in this case, the data type is employee. So we're saying for each employee, current employee, which is the variable name, in current employees, I want you to tell me what the current employee is to string. If current employee, this is in the for each statement, by the way, I think. Yeah, it is. If the current employee is base commission employee, then I want you to turn that current employee into a base commission employee data type with the employee variable. Do some magic here, and then leave the for each loop. Now, here's a for loop. For int j, doesn't matter what you call that. You can call this whatever you want. That's just a variable name or the iterator name. Int j equals 0, while j is less than employees.length. Employees, once again, is the array. J++, you can get the type of the employees. What's the type of employee? Let's go back. So employee at the 0th position is the salaried employee. What's that type? Well, if we go back and look at when we instantiated salaried employee, you can see that salaried employee is the data type of the salaried employee variable. So if I keep going and go back to where we were, you will see that I want the type of variable that employee is. And here it is. You have employee number 1, John Smith, Karen Price, Sue Jones, Bob Lewis, John Smith, and Karen Price. All processed polymorphically. And this will tell you what they are. Employee 0 is a salaried employee, hourly employee, commission employee, base plus commission employee, and that's that. Assigning a base class variable to a derived class variable without an explicit downcast is a compilation error. If at execution time the reference to a derived class object has been assigned to a variable of one of its direct or indirect base classes, it's acceptable to cast the reference stored in that base class variable back to a reference of the derived class type. Before performing such a cast, use the is operator to ensure that the object is indeed an object of an appropriate derived class. Using is the equivalent of kind of doing this. That's a strict type equalitor. Not equalitor. Oh my goodness. Equals. I'm not saying that. Equals. Strongly typed. This asks for both whether or not everything on the left is equal to the right, and if it's the same data type. For instance, if this was written like this, string 0 is equal to integer 0, this would be false because the data types are not the same. Both the data types and the values both have to be the same for that to be true. You can avoid a potential invalid cast exception by using the as operator to perform a downcast rather than a cast operator. If the downcast is invalid, the expression will be null instead of throwing an exception. The method getType returns an object of class type of namespace system, which contains information about the object's type, including its class name, the names of its methods, and the name of its base class. The type classes to string method returns the class name. Assigning a base class reference to a base class variable is straightforward. Assigning a derived class reference to a derived class variable is straightforward. Assigning a derived class reference to a base class variable is safe because the derived class object is an object of its base class. However, this reference can be used to refer only to the base class members. Attempting to assign a base class reference to a derived class variable is a compilation error. To avoid this error, the base class reference must be cast to a derived class type explicitly. So, for the most part, these two are kind of complex. Just understand that using the base class reference within the base class variable is fine. Using the derived class reference, meaning that earnings override, using the derived class reference in the derived class variable, okay. These two things, just ignore them. Don't even go down that road. Keep it straight. Keep it simple. KISS. A method declared sealed in a base class cannot be overridden by a derived class. Methods that are private are implicitly sealed. Methods that are declared static also are implicitly sealed because static methods cannot be overridden either. The derived class method declared both override and sealed can override a base class method, but cannot be overridden in classes further down the inheritance hierarchy. Calls to sealed methods and non-virtual methods are resolved at compile time. This is known as static binding. So, remember when I said that all methods that are called abstract, all properties that are called abstract, must be overridden at every derived class that inherits that abstract method. Well, if you classify that method as sealed farther on down the line in the derived class, you don't have to override that method anymore for any other class that inherits from that derived class. So if shape had an abstract method, then circle would have to override it. So would square. However, if the square overrode the shape abstract method, but then said that its method was sealed, then every class that inherits from square no longer has to override the method that shape called abstract. That's what this is saying. Sounds a bit confusing, but it makes sense when you do it. The compiler can decide to inline a sealed method call and will do so for small, simple sealed methods. Inlining does not violate encapsulation or information hiding, but does improve performance because it eliminates the overhead of making a method call. A class that is declared sealed cannot be a base class. A class cannot extend a sealed class. All methods in a sealed class are implicitly sealed. Remember, sealed means private. So if you seal a method, so let's say that, once again, shape has a base abstract method that is being pushed down to quadrilateral. Quadrilateral then wants to push that method as well, but quadrilateral called that method sealed. That method is no longer accessible to anything outside of these two methods, the abstract version and the sealed version. Sealed being private, because when you make something private, it privatizes that object within the class that it's in. So if I had square after quadrilateral, that method that we sealed is not accessible to square. Class string is a sealed class. This class cannot be extended, so apps that use strings can rely on the functionality of string objects as specified in the framework class library. Attempting to declare a derived class of a sealed class is a compilation error. So, interfaces define and standardize the ways in which people and systems can interact with one another. A C# interface describes a set of methods that can be called on an object to tell it, for example, to perform some task or return some piece of information. An interface declaration begins with the keyword interface and can contain only abstract methods, abstract properties, abstract indexers, and abstract events. All interface members are implicitly declared both public and abstract all the time. You cannot make a private method or a property in an interface. You can't. They are all abstract and they are all public, meaning that when you create an interface, the interface itself does not contain implementations. The interface only contains abstractions. An interface can extend one or more other interfaces to create a more elaborate interface that other classes can implement. So, if interfaces and abstract classes do the same daggone thing, why do I care to have abstract classes? Why not just do interfaces? And that's the conundrum that we're in right now. It's a compilation error to declare an interface member public or abstract explicitly because they're redundant in interface member declarations. Do not, in the interface, call public. If I want to write an interface, I don't say public void. I just say void. Public is implied. If I'm writing an interface, it knows that it's public. I don't have to say public abstract void. I just say void. Why? Because in an interface, everything is public abstract. Everything. To use an interface, a class must specify that it implements the interface, or it must express that it is inheriting the interface by using the colon. A concrete class implementing an interface must declare each member of the interface with the signature provided in the interface declaration, meaning that everything that is being provided in the interface, all the method calls and properties that are in the interface must be written as concrete methods and properties in the derived class, or in the concrete class, my apologies. A class that implements an interface but does not implement all its members is an abstract class. It must be declared abstract and must contain an abstract declaration for each unimplemented member of the interface. Just implement everything. Don't write a method into the interface that's an abstraction, but you're not implementing it inside of your class, because what that essentially does is it creates an abstraction of that interface, and you have to override that everywhere you go. You do not want to have to do that. Failing to define or declare any member of an interface in a class that implements the interface results in a compilation error. So let me, just for the record, let's go ahead and write an interface, shall we? Let's not write an interface, but let's make one. So I'm going to make an interface for, let me see. This is commission employee, yeah. So let's make an interface for it. Actually, commission employee. Yup. Let's make an interface for commission employee. Not new project. What am I doing? There we go. Add. I want to add a new item. I want to add an interface. And it doesn't matter because interfaces are classes. That's really all they are. I'm going to name this iCommission employee. Why am I naming that? Because I tells me that I have an interface. So now what I need to do is I need to extend commission employee to implement iCommission employee. All right. Done. Right? No, I'm not done. What I need to do is I need to take all the methods that I'm running in commission employee, which looks like I'm only running one for the most part, earnings, and I need to put that, that was not right, into the iCommission employee, so that when I instantiate iCommission employee, it will run an instance of commission employee. So in iCommission employee, I'm just going to write the abstraction, which looks something like this. Okay, and I don't need to make this virtual. Stop. Ooh, yeah, there we go. And that's it. If I change this, let's say I wanted to add a variable here. Let's say I want to say int number. What? I will get an error from the interface. What does it say? Commission employee does not implement interface member iCommission employee earnings. So what I need to do is, in order to stop this error from occurring, I have to make sure that the call earnings matches the call here. So I would have to say int number, and the error should go away. Now, whenever I wanted to use this, whenever I wanted to use a method that exists here in commission employee, I wouldn't call it from commission employee. I would call it from the abstract interface. This, I always say iCommission employee equals blah, 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 blah. And this is encapsulated behind the interface. That's how that works. An interface is typically used when unrelated classes need to share common methods so that they can be processed polymorphically. You can create an interface that describes the desired functionality, then implement this interface in any classes requiring that functionality. As a matter of fact, the one great thing about interfaces is that they can be inherited more than once. Base classes cannot. An interface often is used in place of an abstract class when there is no default implementation to inherit. That is, no fields, no default method implementations. For the most part, interfaces are exactly what you're going to use instead of abstract classes because they're abstract in nature. As a matter of fact, I can take that a step further and tell you this. Interfaces are how we use and extend dependency injection. So we don't really use abstract classes because abstract classes allow concretions. But remember what I told you in the beginning. Concretions are not what we want to use. Yes, there are instances where concretions matter. But in most situations, if you need to create an abstract class, for the most part, you can create an interface instead. It's more powerful, it can be inherited multiply, or it can provide you multiple inheritance, and it's thin and easy to use. Oh, and also, interfaces, you don't have to override the abstract classes when you want to use them, like you have to do with abstract methods. That goes away. I don't have to do that anymore. I just say, hey, listen, use the interface and we're good. Like abstract classes, interfaces are typically public, so they are normally declared in files by themselves with the same name, and I just showed you that. To build an app that can determine payments for the employees and invoices alike, we create an interface called, oh, look at that, iPayable. I wonder why it's called iPayable. It's called iPayable because it's interface payable. Interface payable contains method get payment amount that returns a decimal amount to be paid for an object of any class that implements the interface. So, and I think it's going to show it to us. By convention, the name of an interface begins with an I. This helps distinguish interfaces from classes, improving code readability. What you can also do is you can create a folder here, and this is what I normally do, and I say interfaces, and I put all my interfaces in that folder. And if I want to use that folder, what I'll do is I'll take commission employee, so stop it, I know I goofed, drag it in the interfaces, and now it exists in interfaces. Obviously, it's going to not throw a problem, so let's delete that. I want it to throw a problem, actually. Alright, good. Did I commission employee go away? It did. Perfect. So I'm going to add it back. But at this time, I want it to sit in the in the interfaces folder. I want to show you what happens. Alright, and then we'll have our abstraction without its implementation. What? Oh, I know why it's doing that. Okay. Where are you? Here. Now, it's not using int number, so I should probably remove it, but for now, I'm going to leave it. All right. Let's look at commission employee. Did it resolve itself? No, it did not. Why? It didn't resolve itself because commission employee does not exist in the same directory as commission employee. What I have to do is come up here and say, oh, I'm sorry. You are no longer there. You are here. Console app, because that's the name of our application, dot interfaces. You see how that showed up? And everything in the interfaces folder will now be available to this class, and now it sees that commission employee, it resolves itself and stops crying. That's the way you do that. Just create an interfaces folder, create a data folder, whatever the case may be, and you'll be fine. And that way you'll always remember what interfaces and classes you have available to you. When declaring a method in an interface, choose a name that describes the method's purpose in a general manner, because the method may be implemented by a broad range of unrelated classes. You can use the same method over and over again with different implementations as long as that method is available to the interface that's being shared across all classes. So that toString method, well, no, actually, the earnings method that is being used by multiple different employee derived classes can exist in one interface. And that interface is then inherited by all of those employee classes, and it has one place that you can call that from. Here's the UML diagram that shows the interface class hierarchy used in our accounts payable app. The UML distinguishes an interface from a class by placing the word interface in guillemets, and above the interface name. And there you go, interface. Treat the interface like an abstract class. And here's iPayable. And that's exactly what I showed, and that is it. Remember to call it public though. Normally, interfaces do not promote themselves as public. If you don't promote the interface as public, what happens? It's automatically private. So, public interface. Unless, of course, using dependency injection, then it doesn't matter. We now create invoice. Represents a simple invoice that contains billing information for one kind of part. And here it is. Invoice is inheriting or implementing I payable. The private int quantity, private decimal per price per item is our private variables. We have public string public property assessors. We then call a constructor on invoice for part, description, count, and price. Notice we did not say we wanted a base, because interfaces for the most part do not allow you to have constructors. You can, I'm not saying you can't, but for the most part, you can't. So notice that there's no base here for the constructor. We don't need it. Go away. And then we have our properties being called, correct? Quantity and price per item. And then the toString being overridden. And then guess what? The public decimal get payment amount that's using the quantity property and the price per item property to calculate the total cost. This is what is being promoted in the interface. C# does not allow derived classes to inherit from more than one base class. I will say that again. C# does not allow derived classes to inherit from more than one base class. I will say that one more time so you understand why interfaces are so powerful. C# does not allow derived classes to inherit from more than one base class. You might find yourself in a situation where you need more than one base class, but it does allow you a class to implement from a multitudinous amount of interfaces. So to implement more than one interface, use a comma separated list like this. Just making sure. If I wanted to add a second one here, I would say I employee. And then I would create, I understand that. And then I would come here, add new item. No, not existing item, I'm sorry. Add new item. And then I would say interface, I employee. And guess what? It's there! I can inherit interface after interface after interface. I cannot do that with base classes. I can only inherit one base class at a time. This is very powerful. This allows you to do a bunch of things that we were not able to do before. When a class inherits from a base class and implements one or more interfaces, the class declaration must list the base class name before any of the interface names. So if you do have a base class, you have to write that name first, and then you can write your interface names. So here we go. Employee class is modified to implement the interface IPayable. So the employee abstract class is then implementing the IPayable interface. It has these read-only properties. It has the constructor for the first, last, and social security number. It has the overridden toString. It has the abstract decimal get payment amount. And that's it. Figure 12.14 contains a modified version of a class salaried employee that extends employee and implements the method get payment amount. The remaining employee-derived classes also must be modified to contain method get payment amount in place of earnings to reflect the fact that employee now implements IPayable. And here we go. Because salaried employee implements employee, the base class will get the first, last, and social security number, where the salaried employee would get the salary. And then get payment amount has to be overridden because get payment amount is where? In the base class as an abstract class. Let's go back and I can show you. It's an abstract class here, therefore it must be overridden in all the derived classes unless it has been sealed. And sealed would go here. And we override the toString because it comes from the employee, which comes from the object class. When a class implements an interface, the same is a relationship provided by inheritance applies. Inheritance and interfaces are similar in their implementation of the is a relationship. An object of a class that implements an interface may be thought of as an object of that interface type. An object of a derived class of a class that implements an interface also can be thought of as an object of the interface type. Yeah, it's very complicated. Just to understand that when you implement an interface, the object that's derived can also be looked at as the interface type as well as the derived class type that you were using. The is a relationship that exists between base classes and derived classes and between interfaces and the classes that implement them holds when passing an object to a method. When a method parameter receives an argument of a base class or interface type, the method polymorphically processes the object received as an argument. So, payable interface test illustrates that interface iPayable can be used to process a set of invoices and employees polymorphically in a single app. All methods of class object can be called by using a reference of an interface type. The reference refers to an object, and all objects inherit the methods of class object. Here we go. So this is the payable interface test main that creates all of it populates the array objects into iPayable. So there's 5 positions in iPayable. We have an invoice concretion, salary employee concretion, and then all of that's getting dumped, or not getting dumped, but it's getting used as the program it parses through. So for each var is nice when you don't know the object coming back. I'll say that again. var is nice when you don't know what object you're receiving back, what data type you're receiving. If you look back here, the invoice object and the salaried employee object are going into the same iPayable array. Remember what I told you? Normally, you have to give a data type to an array and it has a fixed amount of positions. In this case, the payable objects is the iPayable interface. But because the iPayable interface is inherited by the base class, all derived classes can use the iPayable interface. Therefore, when you dump the invoice data type and the salaried employee object data type into the payable objects array, it doesn't matter. It likes it and converts everything that comes out of this to iPayable. So, when we do this for each statement, we can say var current payable, which is the variable of the object that's being iterated on. So for each will go, okay, is there something in the 0th position? Cool. I'm going to put it into the current payable, and I'm going to do something with it. Then it goes to the first position. Is there something in the first position? Okay, I'm going to put that in the current payable, and then I'm going to do something with it. Is there something in the second position? Yep, there is. I'm going to put it in the current payable. You see how that works? So I'm looking at the payable objects array. I'm iterating through it and putting one by one each object in its position into the current payable and then doing something to it. In this case, I want to calculate get payment amount from current payable. Where is that? Do you remember where get payment amount was? I do. It was in the base class. It was a abstract class that had to be overridden in the salary class. So where we have current employee being the object, or current payable being the object now in invoice, and current payable being the object in salaried employee, I can say, okay, well, I want to use that object, and then I want to use the method that's in that class. And then it does its stuff. So, 1216 overviews several commonly used framework class library interfaces. And these are interfaces that are already written into C#. iComparable, there's iQueryable, there's iDisposable. This is the one that's very important. It disposes of objects that are sitting in RAM needlessly. It's a garbage collector. And iEnumerator. There's iQueryable as well now. And iQueryable allows you to use SQL queries on lists. Lists are dynamic arrays. And you can write SQL queries like, for X in cust or whatever. Select cust. And then what it'll do is it'll give you only the values that you look for. So where blah, 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 blah. iQueryable is really nice. iEnumerator allows you to iterate through a collection of an array or a list. Without iEnumerator, it won't work. Or iEnumerable. You can overload most operators to make them sensitive to the context in which they are used. Class complex number overloads the plus, minus, and multiplication operators to enable programs to add, subtract, and multiply instances of class complex number using common mathematical notation. So, complex number wants a real number as a property, an imaginary number as a property, and it uses a constructor to get them. So A is the real number, and B is the imaginary number, which is assigned to those properties. We then override the toString to give us a printout. The overriding of the toString comes from, where is the toString method coming from that we're overriding? It is in the... Do you remember? It's in the object class. The object class is inherited by all classes. We're overriding the toString so we can write based on what we want. Then, we do some stuff. Public static complex number operator plus will do a plus of the real and a plus of the imaginary. Oh man, what am I doing? The same thing for minus. And then public static complex number operator multiplication for multiplication. And then returns a new complex number. Look, new complex number. New complex number. It's returning an object. This is sort of the way that we do what's called factory patterning. We return a new object from the factory. But that's a long story and I'm not going to go into that. Keyword operator followed by an operator symbol indicates that a method overloads the specified operator. Methods that overload binary operators must take two arguments. The first argument is the left operand, and the second argument is the right operand. Overloaded operator methods must be public and static. Overload operators to perform the same function or similar functions on class objects as the operators perform the objects of simple types. Avoid non-intuitive use of operators. At least one parameter of an overloaded operator method must be a reference to an object of the class in which the operator is overloaded. This prevents you from changing how operators work on simple types. This is all math. Don't get all bent out of shape about it. All it's saying is that if you use the word operator and then you have the assignment or the mathematical expression, then you must do a expression on the left and right side. That's what that means. Class complex test demonstrates the overloaded operators for adding, subtracting, and multiplying complex numbers. So we have the main. We have complex number x and y, but we didn't do any concretions yet. All we did was initialize those variables. We then said we wanted to enter the real part of the complex number x. The person enters it. We convert it to a double. They do the same thing for the imaginary part. We convert that to a double. Then we add those two numbers, or those two variables, and we create a new complex number that gets assigned to the x variable. Remember, the x variable is created here. It was initialized before this all occurred. The same thing happens with the y. And then it writes it all out. This is why they don't want you to take computers and stuff to do your algebraic expressions. And that's it. So hopefully that worked out and it made sense and it was something that you can use going forward. But otherwise, I'm grateful that I could help you and give you all the knowledge that you need. Otherwise, if you need any help, just reach out and I'm here for you. Good luck. You might have to watch this more than once, but in the end, it's simpler than it looks. It just seems complicated because there's a lot of moving parts. But I have the faith you can do it. Either way, good luck. Congrats. This is the last week. And ciao.